Hello everyone, welcome to today's lecture. In this lecture, we are going to discuss about IoT levels and deployment templates. So let's first we start with the deployment templates. So there are totally 6 deployment templates. It is based on the complexity of the application. So here we can say that the deployment templates means the infrastructure and the configuration of your IoT project. So what types of configurations or infrastructure required to build the IoT application. So these are the deployment templates. So the first template is the device. Now we all know for identification, sensing, actuating or monitoring, for monitoring capabilities we require the IoT device. The device may be a wireless sensors or the software or the actuators or the computer devices. So they are attached to a particular object that operates through the internet, enabling the transfer of data among the objects or the people automatically without the human interventions. So all the devices are connected together. They will communicate with each other without the human intervention. So this is the first template, which is the device. The second is the resource. What are the resources used by the IoT application? So these are the software components on the IoT device for accessing, processing and storing the sensor information or controlling the actuators connected to the device. So we can say that the resource are the software components. We are storing the sensors information or controlling the actuators, so that can be done with the help of resources. The third is controller service. Now it is a native service that runs on the device and work between node device and web services. Controller service sends the data from device to the web service and receives the command from application for controlling the device. So controller service is a type of controller which controls the activity, like it sends data from device, and with the help of web service the data will be sent to the application. Same as from application, with the help of web service the controller service will provide data to the applications. The fourth one is database. Now we all know that the sensors are getting the lots of information, or sensors will generate the data. So that generated data, so we have to store that generated data to locally or on the cloud base. So this is the database. So that is why database is required. Next is a web service. Now we all are aware with web service. So web service are the server as a link between IoT device and application database and analysis components. And with the help of web service, the data will be transferred from one location to the another location. Web service can be either implemented using HTTP and the REST services, or using the WebSocket protocols. So we'll implement the web service which is used to transfer the data between one device to the multiple device. Next is the analysis components. So these are the responsible for analyzing the IoT data and generates the result in the form which are easy for the user to understand. Now we have a lots of data that is stored on locally or on the cloud base, but with the help of this data we can find some important information or important knowledge. So for that we require the analysis, and based on the analysis components will generate the result, and based on that the action will be performed by the IoT application. And the last is the application. So IoT application provides an interface that user can use to control and monitor various aspects of the IoT system. It allows user to view the system, monitor and process the data. Now the application is installed locally or the cloud or on the cloud, and user can use that application and also view the system, or user can monitor and process the data. So this is a user interface of the IoT device. So these are the 6 IoT deployment templates. Now the next topic is IoT levels. Here IoT levels means what type. There are totally 6 types of IoT levels, and that is based on the complexity of the IoT application. Suppose if you want to if you want to create a simple application with the low cost, at that time the IoT level 1 is useful. If you want in complex application, at that time you can use level 4 or level 5. So as the level increase, the complexity of the IoT application will also increase. So let's start with the IoT level 1. So IoT level 1 system has a single node device that perform a sensing and actuating or storing the data, that perform analysis and host the application. Now as seen in this figure, there are total 2 department here. This is a cloud base and this is a local dev. So in the level 1 application, all the configuration is made locally. There is no communication or there is no use of cloud. Yes, so here in the local device there is an application, also the REST based service. Your database is also stored locally. There is one controller service, resources and devices, and also the monitoring or analysis of data is also done locally in the level 1 system. The data is stored locally. Here one thing we need to understand, that here we are storing the data locally. So here the size of data is not that much big. The size of data is less. So that is why we can store it locally and process or analyze the data. So this is the level 1. Here level 1 is the low cost and low complexity solution. Here low cost means here we are not using any cloud resource. So and we are doing all the work locally. So the application is a low cost and low complexity. Here we are not using any cloud based analysis or cloud based data storage, so we do not require or we do not need to make the connection to the cloud. So that is why the level 1 application is in the low cost and low complexity. So we can say that if you want to implement the system in term low cost and low complexity, or if you want to implement the simple system in which you do not want to include the cloud, at that time you can use the IoT level 1 system. The second is IoT level 2. Here I see in this figure, here in the IoT level 1 the node is only a 1. Okay, so here we can IoT level 1 is only supports a single node device, same as in the IoT level 2 it has a single node, means there is only a one node or the one computer, and that performs the sensing or the actuating and local analysis. Okay, so as shown in this figure, the device, resource and control service that is set up on the set up locally, and on the cloud the application is set up and the database, means storage, is also at the cloud side. So here the devices sends the information or the data through the web service or the REST API. Now here device will generates the data, and the data is gathered by the resource, and that data will store to the database that is on the cloud with the help of web services like REST or the WebSocket service, and that is stored over the cloud. Here in this figure you can see that the application is also installed on the cloud. So user application is also installed on the cloud. Here one thing needs to notice, that here monitoring and node performance analysis is done at the locally. So the data is stored at the cloud, so with the help of web service the data will be fetched and the analysis is performed locally. So in the IoT level database, the IoT level 2 database and application established in the cloud, it is useful for solution where the data involved is big. However, the primary analysis requirement is not computationally intensive and can be done locally itself. It means that if you want an application where you have a lots of data, so at that time you can use the level 2 system where we can store the data over the cloud, and here we are performing analysis locally. So here we can use this system where the analysis requirement is not computationally intensive. So here if your analysis is the basic or at the simple, at that time you can use IoT level 2. Now the IoT level 3. So in this figure you can see that here application, database and analysis. All these things is done at the cloud level. So it has a single node. This is also used IoT level system. IoT level 3 system is also used when you have a single node. Database and application established in the cloud. Also the analysis, data analysis is also done at the cloud. It is suitable for the application where the data involved is big and the analysis requirements are computationally intensive. So if you have a big data, so you can store over the cloud, and if you require intensive analysis, at that time the level 3 system is used because the analysis is also done at the cloud. Now the next is the IoT level 4. Here in this figure you can see that here there are multiple monitoring nodes. Okay, here multiple nodes. So if you have a multiple nodes, at that time you can use IoT level 4 system. In the IoT level 4 system, suppose here there are 2 nodes, so at that time 2 device, 2 resources, controller service, all set up locally, and at the cloud the application is installed, the REST services, database, and the database is also installed over the cloud. Here you need to observe that there is one observer node here which is connected to the REST service, and this observer node is at local side, here at the local side and at the cloud side. So both side there is one observer node which is connected to the REST services. So here you can see that the local observer node is also connected with the REST service, and the cloud observer node is also connected with the REST service. So it means that observer node observes the web service or how the data will be transferred from one device to the another device. So it has a multiple nodes that performs the local analysis. Here the analysis is not done at the cloud. The analysis is done locally. So it has a cloud-based application and database. This IoT system contains local and cloud-based observer node which can subscribe to and receive information collected in the cloud from IoT node devices. So as you can see, this observer node is connected with the REST service, so it will observe the data that is received or collected at local service or at the cloud. It is suitable for solution where we are using multiple nodes, the data involved is big, and the analysis requirements are computationally intensive. So at that time you can use this IoT level 4. Next is IoT level 5. It also supports the multiple nodes, and in this figure you can see that these are the endpoints, and these endpoints are connected with one coordinator, and this coordinator is connected to the cloud. So we can say that this one coordinator is connected to all the end nodes, and these end nodes will communicate to the cloud via coordinator. So it has a multiple end nodes and one coordinator node. The end nodes used for sensing and actuating. So these endpoints are used for sensing and actuating activity. In this model, coordinator nodes collects the data from the end nodes. So here the data that is collected by the end nodes is collected by the coordinator nodes, and this coordinator node will transfer the data to the cloud. So in this model we use the cloud-based database for storage and analyze the data. So here you can see that this is a cloud application and this is a local application. So in the local application there is an endpoints, resources and control services, and there is one observer node which is a coordinator between the local endpoints and the cloud, and this is connected to the web services of the cloud. The data is also installed over the cloud. This application is also installed over the cloud, and this REST service is also connected with the observer node of the cloud, and analysis is also done at the cloud. So in the level 4 the analysis is done locally, but in the level 5 analysis is done at the cloud. So it is suitable for solutions based on wireless sensor networks in which data involved is big and the analysis requirements are computationally intensive. So at that time you can use the level 5. The next is a level 6. So the only difference between level 5 and level 6 is here in the level 5 there is one coordinator node, and here in the level 6 there is a centralized controller. So the rest of the things are same. The only difference is there is one centralized coordinator in the level 6. Here these are the multiple end nodes that is connected with the centralized node, and this centralized node is connected with the cloud. So it has a multiple independent end nodes. It also supports the multiple nodes. And these end nodes are used for sensing and actuating and data transfer, actuation and transfer data to the cloud. We use a cloud-based storage. So here in the level 6, the data is stored at the cloud. The analytics components analyze the data and store the results in the cloud database, and results are visualized with the cloud-based application. So here there is one application. It is also installed over the cloud. Analysis is also installed over the cloud. So result of the analysis will be displayed over the application. The centralized controller is aware of the status of all the end nodes and sends the control commands to the nodes. Here the centralized node is used to know the status of all the end nodes. Okay. Now if you want to perform some action by the end nodes, at that time the centralized server gets the status of all end nodes, and as per the requirement, centralized controller sends the commands to the end node, and the end node performs some activity. So this is the IoT level 6. So that is all about the IoT levels and deployment template. So that's it. Thank you so much.